compare three states of matter. Remember, we said matter can be solid, like ice, or it could be liquid, like water, or it could be gas, like steam. So what is the difference between three states of matter? The difference is energy. If you apply energy, if you heat ice, for example, you're applying energy, it's going to be converted to liquid. And if you heat liquid, if you apply energy to liquid, it's going to evaporate and make a gas. So energy content makes a difference. So if I look at ice, which is a solid, compare it with sodium chloride, they are both solids. Ice melts at 0 degree of Celsius, but sodium chloride melts at 800 degree of Celsius. The question is, why different solids have different melting point? Why salt needs more thermal energy to melt than ice? So it depends on how strongly the units of solids are holding each other. So we call these forces intermolecular forces. So what is intermolecular forces in sodium chloride? Well, we know that sodium chloride is made out of positively charged sodium and negatively charged chloride. So opposite charges attract each other. They attract each other. They attract each other here. These are attractive forces between a full positive, full negative charge. We call this ionic bond. What is the strength of this force in case of ionic compound? This could be between 150 to 3,000 kilocalorie per mole. So if you want to melt sodium chloride, what should we do? We should break this bond, this bond, this bond, this bond. So molecules of sodium chloride ions are free to move around each other, because in solid, molecules are not free to move. They may oscillate, but they are not free to move. In molten sodium chloride, in liquid water, molecules are moving around each other. Although they are in contact together, but they go around each other. They move around each other. They have enough energy. So breaking a bond needs energy. That's why melting is going to need heat. The stronger the bond between particles of a solid, the more heat you need. So this is one type of intermolecular forces, which is called ion-ion bond or ionic bond, and this is a very strong force. Energy 150, depending on the ionic compound we are talking about, 150 to 3,000 kilocalorie for 1 mole of solid. So is there another type of force between units of a solid? Well, let's talk about water. As water freezes, if it is freezing, if it is becoming a solid, it means there is a type of interaction. Is water ionic? We know water is not ionic. Remember, these bonds in water are covalent bonds. So it's not the same type of interaction in sodium chloride. But do you remember when we talk about water, we said water is polar. There is negative end, which is oxygen, and there is positive end, which is in center of the 2 hydrogens. So because of that, we said water is polar. That's how we show. We show an arrow to show movements of electrons going up from hydrogen to oxygen. That's how we show polarity of water. So if we have positive and negative, it's like having a magnet. Can I say a magnet has got north and south pole? It has negative pole and positive pole. You throw magnets together, what do? If you have a bunch of magnets, throw them together, they will rearrange themselves for opposite pole to attract each other. So the same thing in water, positive end of one water molecule is, look here, it is attracting the negative end of another water molecule, which is oxygen. So hydrogen and oxygens are attracting each other. So look at this attraction. It's much smaller than ionic attraction. Remember, look at the strength of ion and ion. That's 150 at least to 3,000. So compare 150 with the strength of interaction in water molecule 5 to 10, at least 15 times smaller. And these molecules are polar molecules. That means they have negative and positive end, and we call them dipole. When two molecules with dipole interact together, we call the interaction dipole-dipole. Look, this is dipole-dipole. One end of dipole is attracting the opposite end of another dipole. Now, it happens that because hydrogen is the smallest atom, it cannot carry positive charge. There is too much charge concentration. So when hydrogen sees negatively charged oxygen, it start attracting, making a bond. This bond is the stronger form of dipole-dipole interaction. Let me give you another dipole-dipole interaction, which does not involve hydrogen. Let's look at these two molecules. There is no hydrogen. You have dipole, negative and positive are attracting together. We're talking about BrCl. Cl is the negative end, Br is the positive end. There is no hydrogen involved. This interaction, the energy of this interaction is 0.1 to 1 kilocalorie. Look at here, at least 50 times more when we compare these two, right? So what I'm trying to say, there are two types of interaction when we are dealing with polar molecules. Dipole-dipole interaction. The ones which contain hydrogen bridging between two electronegative atoms. These are oxygens of electronegativity. Electronegative. Sorry, my slides are jumping again. So when hydrogen is involved, interaction is a stronger form of dipole-dipole form. So I call this hydrogen bonding. If there is no hydrogen involved in dipole-dipole interaction, we call them simple dipole-dipole. So hydrogen bonding is a specific case of dipole-dipole, which is very strong. But both of them are happening in covalent bonded molecules. So can I say now, so far, we know three types of interaction. One is ion-ion interaction. The other one is hydrogen bonding. The third one is dipole-dipole. So all of these are resulting a liquid to become solid. If it wasn't for these interactions, then we wouldn't have had solid. So solid is result of interaction between molecules. Of course, liquids have interaction as well. Interaction between molecules are much weaker in case of liquid relative to solids. And then we have one more case. And that case is, this is, by the way, this is showing a typical dipole-dipole interaction. If there is no hydrogen involved between the two electronegative atoms, we call it dipole-dipole. If there is a hydrogen involved, like here, hydrogen is bridging two electronegative atoms of nitrogens together. It is a special case of dipole-dipole. We call it hydrogen bonding. Look at here. Hydrogen is bridging between two electronegative atoms of oxygen. Hydrogen bonding. So hydrogen bonding is a special case of dipole-dipole. It happens only when hydrogen is sitting on three atoms. Well, if hydrogen is sitting on oxygen, that's one case. If hydrogen is sitting on nitrogen, that's a second case. And the third case is when hydrogen is sitting on fluorine. For example, if I want to write here, let's say here, H, I write HF, and HF, there is this hydrogen, this is negative, this is positive, they're attracting each other. So we only observe hydrogen bonding when it's sitting on these three atoms, oxygen, nitrogen, and fluorine. In other cases, hydrogen sitting on carbon, for example, cannot make hydrogen bonding. Do you have any question? Are you with me? Don't hesitate to ask a question if I don't make sense.
So you said there's 3 or 4 ways from going to liquid to solid. You said hydrogen bonding, you said dipole-dipole, and there's something to do with iron, right?
Ions, yes. So I haven't talked about the fourth one.
Oh, okay.
I think that's what your question is.
Okay.
Good job.
Yeah.